on your NOI submissions. We know some of that's going to change, but just what we saw got us excited. And so this is such a fun challenge for us. And we received a lot of really good questions. We received a lot of common questions from everyone. And so we know that there's some areas that we definitely need to provide some clarifications on, and we're excited to be able to do that today. I'd like to ask you, if you haven't already, just to go ahead and mute your mic. And if you want to turn your camera off, that's a-okay. We're going to have PowerPoint slides up most of the time. So that'll be the focus of today versus looking at each other or looking at whoever is speaking. We do have the use of the chat function. So if you have some questions along the way and you want to throw them into the chat, what we're going to do is, and Tori, if you go ahead and move to the next slide for me. This is kind of the flow of what we're going to do today. We'll just start off with some welcome and introductions of our staff and our judges. We'll provide just a quick kind of framework for the challenge, go over some of those common questions that we got that require a little bit more clarification from the staff and the judges, and then to go through basically almost verbatim the questions that we received in advance and go through some of those answers. And then we do hope to have time at the end for additional questions. So that's where, if you want to pop those questions into the chat, we will get to those questions in the order that they come in right at the very end, and we'll wrap up with a few reminders about what's coming next and let you guys be on your way this afternoon. So Tori, if you go to the next slide. Before we jump in too much further, I just want to let everybody know that this session is being recorded, and it will be posted to our FAQs page and emailed out to each of the team leads and the advisors who submitted an NOI. So you'll be getting that plus an actual written transcript of all of the questions with their full answers. So today we're kind of going to give you the overall answer, just kind of a quick answer, but there's much more in-depth answers to each of these questions. So definitely take a peek at those, share them with the rest of your team, and we hope that this will provide a really good resource for you to be able to go back to and refer throughout the year if you have questions that come up. So as I mentioned, myself, Stacy Dees, program manager. Our team is led by Shelly Spears, who manages a very big portfolio of programs all the way from kindergarten through postdoc. We also have on the line with us today Victoria O'Leary. She is the Senior Program Coordinator on the Big Idea Challenge. So you'll be seeing lots of emails from both Tori and I, and maybe a few phone calls along the way. Janice also supports our team. You'll see her probably more at the on-site forum if you're selected as a finalist, and she does a lot of our background media and communications things for us on this challenge. The next slide, we're going to show you some of our judges, and we have full bios for each of these judges on the Big Idea Challenge website, so we hope that you've had a chance to go and look at them and see, but we have a superstar panel of judges here. These are folks who are subject matter experts in this field. They're at the top of their game. They are in very important positions with NASA and industry and the NASA Jet Propulsion Laboratory, and we couldn't be more pleased to have this wealth of knowledge and expertise serving as the folks who are guiding this program and who will be evaluating each and every one of your proposals. So to begin with, we have Dr. Adrian, and I'm not sure how to say your last name, Adrian. Can you say it for us?
Yeah, Adrian Stoica.
Stoica, okay. And we'll be hearing a little bit more from him. We also have on the line with us Kevin Kempton, who is from NASA Langley Research Center and served as a Big Idea chair for several of our other challenges in the past. And you can see here some of our other judges are listed: Jennifer Lopez from Astrobotic Technology, Trent Martin from Intuitive Machines, Dr. Marco Quandrelli, am I saying that right? From NASA.
It's Marco Quandrelli.
Quandrelli. Marco, are you on? Did I hear Marco?
I bet she gets that all the time whenever she goes to the restaurants, you know.
Hey guys, there's a couple people who might not be muted. We're hearing a background conversation. Dr. Eddie Tunstall is also one of our judges from Motive Space Systems, Dr. Vandy Verma from the NASA Jet Propulsion Laboratory, and Dr. Chris Sackney from Honeybee Robotics. So I'm going to go ahead and turn the microphone over to Adrian. And, well, actually, I guess, yeah, let's go ahead and have Adrian give us a quick background. Tori, you should just go back to the Yeah, we'll just hang out here while Adrian talks, or we can put the screen
All
on
right.
Adrian. He's just got a few comments for us here.
All right. Good morning or good afternoon, depends where you are. So I'm Adrian Stoica. I've been at the JPL for over 25 years. About 10 years of those, I manage one of the robotics groups here at JPL. And a few years ago, I worked on a concept of redirecting sunlight onto shaded areas at the lunar poles. And since then, I became very passionate about lunar missions. Um, we believe there is water in lunar craters at the poles. We have great interest in the subterranean exploration, going to lava tubes and so on, to give some examples. And both for supporting human missions and for performing robotic operations, access of extreme terrain is paramount, because it is these locations of highest interest on steep, rugged terrain and so on that we cannot go with the current mobility platforms. And I mean by that the standard wheeled rovers and so on. And that's why this competition is very important. We expect you to come with novel mobility solutions that would open basically a new age of exploration in highly valuable but difficult terrain. I'm grateful I was brought into this competition by my colleague from Langley in headquarters, Kevin Campton, to whom I thank, and I'd like to pass the microphone now. Thank you, Kevin.
Yeah, thanks, Adrian. As you know, a lot of the most compelling and, of course, scientifically interesting locations on the moon and in Mars are located in extreme terrain. You look at Valles Marineris on Mars, you look at some of these craters on the moon, you have the steep slopes, you have the really interesting geology on the layering, so you can tell the history. So we really want to get into some of this extreme terrain and find out what's there, as well as, there's a lot of exploration uses for getting things on high ground for line of sight and things like that. And wheeled rovers just won't get us there. So we're looking for alternate solutions, and we're looking for interesting use cases to do that. So I want to also add, Adrian brought on this competition. This is probably one of the most realistic things you'll do while you're going to college as far as real life engineering. You don't have a preset solution that you've got to do. You've got to think out of the box. You've got to propose what your ideas out to other people and convince them that it's a good idea. And when you go into your job resumes, and it's going to be a great nugget on your job resume. And when you go into your job interview, you can tell stories about, the things that you did on this type of activity. For this kind of thing, you've got to do a lot of project management. You've got to do systems engineering, and you've got to do all the things that we do in space system development. So I think if you go through this, you're going to get a lot of value. And I will add that this is partially funded by the Office of STEM Education, as well as the Game Changing Technology Development Program Office. And so they're very interested. And we want you to learn a lot. So we're looking forward to your proposals and encourage you to learn as much as you can.
Great, thank you both. Tori, let's go ahead and go to that next slide, if you may. So just a couple of things. You guys obviously already know what the theme for this year's challenge is, submitting those NOIs and having some interesting concepts for us. I just wanted to share a couple of things to serve as a little bit of encouragement for you, and also looking at some pitfalls and things that we've seen in the past that have been detrimental for some of the teams proposing. So first of all, this year's challenge is really, it's unique in the fact that it's a competition with super limited constraints. We want you guys to be able to use the creativity that you have and really just have an opportunity for open innovation, to think outside of the box. And we don't want to constrain you on things like mass, size, volume. We want you to tell us what those are. But we also know that when you're telling us what those are, that you have to be thinking like a NASA person. And so, you may have something that you need or you want to be 100 million pounds or something like that. That's not going to fly. That's not going to be possible. NASA is really interested in making sure that things are cost effective, which means smaller, and can be packaged into smaller spaces, and can weigh less. And so those are things that you need to consider, trades that you'll always be making back and forth. But as long as you can justify why you need what you need, that is going to put you in a really good position in your proposal. So Be creative and justify reasons why you need everything. Your proposal is an opportunity for you to sell the value of your proposed concepts to the judges. So as you're writing your proposals, think about making sure that you are being your own best salesperson and pretend like you're on Shark Tank and you are just pitching your best ideas out there to the judges. That will go a long way for you. In terms of other student challenges that are out there, there's really a lot of significant funding available for this particular challenge. Offering up to $180,000 per team is not something to sneeze at. And we know that you could probably all benefit with even more than that, but that's how much we have. And so with that significant funding and the extra time that this challenge has, it spans over and across multiple academic calendar years or academic years. We really want you guys to be able to have the time to do significant and meaningful testing, to be able to demonstrate your concept. So that's a really cool and unique thing about the challenge. One of the things that has come up in the past, and we just want to make sure that we're absolutely clear about up front, is that Big Idea Challenge funds really can only be used for new work. So if you're already receiving funding on some sort of a mobility platform, you can't use these funds in the same way. You could augment an existing award for that if you can prove how you're spending the new funding in a new way, if that makes sense. So if you are tacking Big Idea onto an already existing program, please make sure that you document exactly how the work is different from what you're doing before and what the new Big Idea funding would support. But again, even if it is tacked onto something existing, you want to make sure that you are following the guidelines of the Big Idea Challenge and staying within the parameters of it. If the two don't mix, then don't mix them if it doesn't make sense. And the very last thing that I just want to really hit home is that the budget for the Big Idea Challenge is probably one of the most difficult and oftentimes confusing budgets to put together out of any student challenge that I've ever seen. And we recognize that, and we tried to make it as simple as we could given the constraints. So as Kevin mentioned earlier, there's two sources of funding that come into the Big Idea Challenge. One source of the funding is the Space Technology Mission Directorate. The other is the Office of STEM Engagement through their Space Grant Fellowship. And so these pockets of money come from different parts of the government, and they have different parts, or they have different requirements on how the funding is spent and where the funding is able to go. And as a result, we've asked you to split your budgets up into two phases. The first phase, phase one, is to kind of kickstart your program, and that is going to be for about the first half of your program. All those funds come from STMD, and they will come straight to your university. And then the second phase of the funding for our finalist teams, that comes directly from the Space Grant Consortium, and it's funneled through your state Space Grant Consortium first. And so for those reasons, each of the two phases of the budget are going to have different requirements. And we want to make sure that if there's any overhead involved from your university, and in phase two from your university and the space grant, that those overheads are attributed appropriately, and that the folks who are in charge of those budgets, your Office of Sponsored Research at the university and your Space Grant Consortium director for your state, has signed off on the budget. They literally will have to submit a letter with your proposal indicating that they have seen, read, and agreed to what's in your budget. Because once you submit a proposal to us, your budget cannot change. If prices go up on things, if you missed overhead from your university, it doesn't matter. We cannot provide any more funds than what you put in your initial proposal for this particular thing. So pay really close attention to that. We've given you a template. You not only have to fill out an Excel spreadsheet that has the two phases and all the different things that you might need to include, but you also have to submit a budget justification and tell us, you know, if you put a materials line item in there for $25,000, you've got to tell us what those $25,000 are going to be used for, and give us a table of what those materials are and an estimate of how much you expect them to cost. So I hope that all of that was pretty clear. And I'm going to ask Tori to move to the next slide. and ask Adrian to address some of the common questions that we had from a technical perspective. Adrian?
All right. So as the title says, extreme terrain mobility, mobility is the focus of this competition. The mobility part shouldn't depend whether there is a human in the loop to do kind of joysticking and so on, because there is a latency and potential interruption of the link. But the mobility should also depend on the specific case, which is defined by the team, whether you're going down in a lava tube or you're going on a slope of a crater. The system needs to do something valuable. We don't define what you're defining, but it needs to be basically able to carry a payload, whether it's a science or a different type of a payload, and you need to determine what that function is going to be. All mobility systems, all mobility platforms and solutions would be considered except traditional wheeled mobility. Again, this is the different thing than the wheeled mobility. So don't need to propose, will not be considered something that's already used in a previous or upcoming mission and so on. And you can have a wheeled system that is involved at a different aspect, not the traverse of the extreme terrain, but maybe getting to there. But that's not part of the system of your focus. You basically, more or less, your mission starts at the lander. So we're not worried about necessarily, how you got on the moon. And also you need to assume very little to be available to you in terms of resources out there. Again, the mobility is the key. There could be communications and so on, but right now, just try to make minimal assumption about an infrastructure on the moon, because we target 2026 and we don't know exactly how much will be available. Clearly will be available more in later missions, but for the early ones, make minimal assumption about gateway and other things to support your infrastructure. Next slide, please. So as I mentioned, target days 2026, as the call says, and if for some reason you have a rationale for a later date, then you would have to justify, and you could discuss it. Because of this date, TRL 4 to 5 is expected at this time, since otherwise you won't be able to increase the TRL to have basically something ready for a mission into this time frame. Don't feel pressed to try to match planning or with a current NASA Artemis type of mission. This could be missions of opportunity that come. Just do your own design for a mission scenario and work the mobility solution for it. We don't give you constraints on mass, power consumption, and value, but obviously you need to realize that taking those mobility platforms out there have an associated cost to it. So, in that respect, if your solution is very, very large and so on, it will be less attractive, and because it potentially either it will be very expensive or cannot reach their stimulus with power. And so on. So you need to be realistic about, the feasibility of your mission into the time frame discussed. Again, if there are some high resource requirements and needs, you need to make a strong justification for those. You need to focus basically in the testing and demonstration to build basically the confidence that the system can operate, the mobility system can operate in the expected lunar environment, and that again. Refers to the slopes, the rugged terrain, the illumination if you need to get the solar power and so on. So, but testing again and demonstration efforts are a very important part of your effort. Next slide. So we're going to go now for. A couple of questions and so on, but some other general remarks. The questions also regarding whether we use certain templates or forms We basically only what it is identified already in the proposal must include guidelines. That's all that it is required. And again, if you have want to present information in a different way for a best method, then you need to kind of justify it. The maturity, the proposal needs to be the convincing level. So you have to have enough information there to convince basically the judges that your concept is credible and valuable, and also to give us the confidence that your team can successfully implement and later on deploy, for example, a solution of this kind. And look again at the evaluation criteria, which were already set, and basically see how we'll be scoring the proposals, and make sure that you address all the criteria, because we'll be scoring based on those criteria. Yeah. At any point, Kevin, if you want to make it, I think you are muted, but please make comments anytime you feel like.
Okay. Yeah, I'll just add a couple things. Like, there's a lot of NIAC fellows in your judges here, and this is the NASA Advanced Innovative Concept. And this challenge is based loosely around a NIAC proposal, where you think of a mission scenario, and then you want to show how your mobility solution will enable that mission scenario. And so the mission scenarios can come from many sources, and just it should be something that NASA needs. And you can, if you're not sure about a mission scenario, go contact some lunar planetary scientists, find out what data they need. Look at the NASA exploration architecture and think about what type of enabling systems need to be deployed, and you can support that. ISRU, there's all kinds of things. And Adrian had mentioned a little bit on the evaluation criteria right here. That is critical. Look at the evaluation criteria and the things that need to be in your proposal, because almost everything in there is just key, solid system engineering things that you need to do. And I'll add one other thing. It's very relevant right now with supply chain things. The sooner you can start thinking about the evaluation methods that you'll use, you can start planning on purchasing any equipment you need and things like that. And so don't start working your concept and designing things. You should be doing the verification planning in advance so that you can order the parts or schedule the facilities you need to do your verification of your system. Because, like I said, with procurement just chews up our teams over and over again. They don't realize how long things take when you start getting in the space business and you order parts that aren't, locally available on Amazon and things like that. So consider that very carefully. I mean, there's much more I could go on about, but it was well covered in this. And as we go through the questions, we'll add a lot more detail on some of these concepts.
Any more comments, Kevin, on the testing and verification or tests?
Yeah, like I said, you want to focus on the tall poles, the highest risk for your mobility systems, and so you don't want to go off and verify something that's really not part of your mobility system in great details, like communications and your computing your computing architecture. Yeah, focus on the things on your mobility system that would reduce the key risks, and anything you do that's sort of cutting edge that hasn't been done before is going to be a great thing that you can promote in the future. Like walking or slithering, or there's a lot of potential there for verifying something that we just haven't verified before in an environment that we haven't really tested out. And so we're looking for you to have ideas on that might enable something completely new and valuable that hasn't been done before.
Yeah, I actually like to emphasize this hasn't been done before. I think it's important for you actually to look at what has been done before and look at the literature, because you can have a novel idea, but that idea maybe it was promoted 30 years ago or 40 years ago or
Right.
at a different time. Again, people have been thinking at lunar missions for many, many decades. And, there is a lot of literature out there. Even especially in terms of scenarios and so on, a lot of them have been proposed and discussed. But some of them may still have limitations in terms of the mobility solution. So it's especially this aspect of mobility that you really need to focus on more. Not necessarily, and again, you may come with a new scenario, but make sure that this scenario may have been proposed somewhere in the last few decades. There may be a lot of information and knowledge that you could get from there.
Yeah. And I'll just add, this is a step beyond ideation. A lot of NASA external challenges are ideation, where you propose ideas and do a white paper. And this one, you get 180,000, and at your level, you can do a lot with 180,000 to build hardware, to test hardware, to get your hands dirty. There's a lot. I get a lot of interns that come in and have never really played with hardware, and so. This is such a valuable thing to be able to do some of that actual hardware work and set up test environments and do these things that you don't normally get to do in the classroom. So take advantage of it.
All right, I'm going to jump in here and have us go ahead and get to some of these questions. I'm actually seeing some questions come in the chat that I already know are going to be answered here, so stand by, guys. Really quickly, before we get into the very first question, I do want to encourage everyone, if you have never heard of this before, Google the Lunar Surface Innovation Consortium, or LSIC as we call it. This is a group of folks from NASA, from industry, and from academia who are all working on 6 key areas of supporting lunar missions, one of them being access to extreme environments. So there's a wealth of workshops and papers and networking that can be done, and anyone can join. So we really do encourage you to join that consortium, and you'll have access to a lot of additional information there. All right, Tori, next slide, please. All right, the first question.
I kind of partly answered that, whether we need to develop new mission scenarios. I think there is a lot of scenarios out there, and there are basically you could use an existing scenario. You don't need to reinvent it. But if you have a concept that is a novel, and again, your mobility can be a solution for something extremely new that hasn't been proposed before, that is also a good aspect. So, but if you can also perform with your mobility concept better on an existing mission concept, that is also a good starting point.
And Adrian, I'll ask a question. I'll ask the question and have you answer it. That way, if somebody is only listening to the recording, they can hear what's going on as well. Awesome. Next slide, please, Tori. At what stage should the mission architecture start at, Adrian?
Well, basically, you can assume that it's already on a lander, and is basically that's where it starts. So if for some reason there is something special that involves the launch or landing portion, you can include that. But for most of the cases, it starts at the lander, and it needs to make its way through the terrain.
All right. And what's the operate?
Sorry, I was just going to add on the mission scenario. Our go-to choice is going to be a CLPS lander because of the potential for great cost savings. And now the CLPS folks, they will take your payload to the lunar surface, and usually it'll be on top of the lander. If you need a system to deploy it from the lunar lander, then that's going to be part of the cost of your system. So the more you can limit specialized robotics or specialized unloading systems or anything like that, it's going to make your proposal more cost effective. But for now, it's a good assumption to use a CLPS lander, unless you have something that requires a much larger payload that normally would come down on some heavy human scale lander for a human landing system. So consider that, and there's a lot of CLPS users manuals and payload users guides out there. So if you can be compatible with a CLPS lander, then you're off to a very credible proposal.
And before we get into the next question, I just wanted to thank Jennifer Lopez, one of our judges, who has been providing some information in the chat about the Lunar Surface Innovation Consortium. And so I started looking through the participants and noticed that we have a couple other judges on the line as well. And I just wanted to say thank you to Eddie, Trent, and Jennifer. And I hope I didn't miss anybody else. Thank you for joining us. And please feel free to jump in on top of anything that either Kevin or Adrian has to say if you have something else beneficial for the group. We'd love to hear from you guys. All right. So, we ready to move to the next question?
Yep.
Next slide, please, Tori.
I think we're already here.
Oh, is this the next one? I'm sorry, I thought this was the one we just, I'm doing too many things here. All right. What should the operational duration of our rover be? Are we talking days or years? What is the lifespan that you expect these robots to have?
Well, I guess one of the critical thresholds here is whether it's longer than 14 days or less than 14 days, because if you're operating in a in a sunlit area, you may receive power into this. But if you have to survive the night, it's a bit different. But in principle, the answer depends on the mission scenario that you're defining. So if it's only something quick and just going into a crater and placing some kind of a probe in there or doing a quick measurement, then you can be a few hours. Then it also can be, again, 10 to 14 days, for example, or even longer. So it's up to you to determine that. Of course, each scenario has different, conditions. So there is no specific fixed requirement to how many days or how many things. But obviously, it will be easier to have it a shorter duration. But your mobility solution itself, other than the power solution, probably should be working in the same way, unless you have dust or other aspects that are affecting your mobility per se.
Yeah, I'll just add, GCD has multiple projects related to lunar technology, and several of them are related to surviving the lunar night. So it's very difficult to survive the lunar night, especially due to the extremely cold temperatures, as all your heat is radiated into deep space. And we have projects like bulk metallic gear boxes that allow very cold temperatures without lubrication, so you can have your gearboxes work, and almost all your solutions will need some type of gearbox more than likely. So there's a lot of things beyond, if you want to go beyond the lunar daylight period to survive, it's a very challenging thing. So consider that.
All right, thank you. Next slide, please. We already discussed there's no additional constraints or guidelines on mass or power or volume. All of those things are up for the team to tell us. However, is there an overall preferred scale on the rover size?
So the preferred scale very much was mentioned, something that can be, transported, and that's basically the packed size of the rover that can be transported on a lander, for example, on a CLPS lander. So, and in terms of the if it can transport or not a person, so that kind of has been specified in there, that the minimum required capability is to carry a science payload, and you will define basically what the science payload is. But again, order of kilograms is possibly a reasonable assumption. And then it's a desired capability, so it's a bonus if it can transport objects much larger than in mass and their own mass. So, but again, wheels are outside of this discussion.
Yeah, I will say for most mobility solutions in extreme terrain, size matters. And so you can do a lot of things with a larger vehicle that you could not do with a miniature vehicle. And so it may be, your use case may be some type of subscale technology demonstration that you can show, hey, this works in an equivalent terrain, and then it should be scalable. If you have a scalable solution, it has a lot more potential for use down road.
Yeah, scalable, and also if you can pack it small but then increase its size over there, that could also be able to reach the larger size, which is useful in this traverses.
Yeah, very true. Large things need much more complex packaging for deployment on the lunar surface. And you also have to consider fabrication. Some things just don't fabricate well when you scale them up. Like inflatables are very difficult to scale up. So,
Yeah, this is Jennifer. Oh, sorry, Stacy.
No, go ahead.
I was going to say, to your point earlier, Kevin, or I don't know if it was Kevin or you, Adrian, when you mentioned about the CLPS landers, that's something to also consider potentially in terms of the mass or the size. To your point, if we're trying to look at cost savings, just something to keep in mind. But I don't know if you have other thoughts there.
that's a good point.
Yep.
And we're also still receiving some questions in the chat, still asking about assumptions for a payload volume. We are not going to be providing any information on good assumptions for any of that. It really is up to your specific rover and what your mission scenario is. People are going to be doing such different things. We can't really provide some good assumptions on that. So you've got to come up with that and tell us why you have selected that volume for your mission scenario.
Yeah, I mean, one kind of a clear limitation is if it's a volume that exceeds anything that future landers are in the next 5-10 years, and again, we are talking about 2026. So you should already know what the upper limits of the volume are.
That's true.
For the overall. All right, next slide, please. So we did receive quite a few questions about what the mass of the science payload would be that you're expected to carry. And so I know we have a little bit more explanation about we're not just looking for science. Your rovers may be doing things that are, resource mapping. You could be doing exploration. It doesn't always have to be just about science. And you all may have very different things. So Adrian, I'm gonna let you address this question.
Yeah, again, kilograms are order of kilograms is normal for small rovers, and you can assume tens of kilograms and up to hundreds of kilograms for the larger vehicles that or platforms that you'll be designing. So this is kind of rough order of magnitude. Again, it needs to do something useful. So basically, it's not only the mobility that it can carry itself, but basically it carries also something that does a useful function, again, for science or for in support of the human mission on the surface.
And the teams can do research on the size of some of these instruments. I'll put in a plug right now. I'm working on Honey, I Shrunk the Payload, supporting that challenge. And basically, they want to put payloads on JPL rovers called Cadre, which are cooperative rovers, and they're the size of a Roomba, but the instrument that we're asking the challengers to build are the size of a bar of soap, and they're doing useful things. You've got neutron spectrometers and X-ray spectrometers and dosimeters, and so the instruments vary in size, but do your research and try to find reasonable values for the dimensions and mass of the instruments that your mission scenario is proposing.
And I think, Kevin, you already kind of jumped ahead to the answer for the next question. So your mind is already in that same place. What kind of science payloads can we assume the rover will carry? And what is the definition of a science payload? And do we need to include any scientific instruments in our prototype?
Well, and again, Kevin addressed that, but again, can be some very simple sensors or a bit more complex sensors. The order of magnitude, again, for volume and for mass has been roughly defined, and again, kilograms maybe is somewhere of the in the center. So you say kilograms, tens of kilograms could be in the center, but it could be smaller, below kilogram, or larger. Science payload will have different placement requirements. So you also, in terms of positioning the science instrument, or where you put it, or in what position you put it, or how long you keep it on a certain orientation, and so on. Those are again specific to the measurement that you do. But in the prototype, you don't really need to include a real functional science operation or science instrument, the kind of the thing that you have in there, but enough to show that the mission would work in there and that the mobility solution supports the instrument.
And again, remember that you don't have to have a science mission component. If your use case scenario is really more based on exploration, doing some remote sensing or infrastructure development, you're not going to have that same type of a scientific payload or mission component.
Yeah, some of these payloads, again, for example, a temperature sensor and so on, could be used for a scientific, purpose, but can be used also for a different thing. For example, in calibrating some of the the navigational capabilities of the rover and so on. So it clearly will have certain types of sensors, but whether they're used for science or for operation per se, again, that's to be determined.
Next question, please.
And of course, dual use systems are also very cost effective. And so if your system can be, if you can change out instruments, science instruments for things that help ISRU prospecting and help move things about the surface, then you'll have a much more cost effective system.
Yeah, agreed. That's a great point, Kevin.
The next question is very similar. What samples should be considered for collection, and what force should be considered to retrieve them?
Kevin, do you want to take this, please?
Yeah, I mean, that goes back to the thing that this is sort of putting the solution into a small subset. Now, it's not, there's no reason that your mission scenario has to collect samples. And so if you, for instance, I mentioned the lava tube scenario where obviously, our precursor missions would want to go in there and just do reconnaissance with sensors and not necessarily bring samples back, so that we can plan for a more costly mission of sample return. And so, yeah, you shouldn't be dedicated to sample returns. But if you do want to collect samples, it's going to be very dependent on what type of samples. If you're going to the permanently shadowed regions and want to extract samples of volatile materials like water, ice, or some of the other things that might be there, frozen methane, frozen carbon dioxide, you're going to have to, when you bring that return that sample, you're going to have to enclose it so all the valuable stuff you have doesn't sublime away. And so there's many ways to do this, and the Viper folks are doing the drilling and things like that. We actually have Chris Zachney. I don't know if he's on the line, but he could tell you more about sample return than probably anybody I know. So.
Next question. Do the collected samples need to fit within a certain volume?
Again, the volumes, first of all, it was answered in the sense of if it needs to be a sample return or sample analysis mission, and the volume is the volume that you have available, whether you do the analysis back at the lander or you try to do a sample return to Earth. So again, all depends on your mission scenario, but in principle, the smaller samples are easier to both to retrieve and to carry back. So, yeah.
What operating temperatures should we design around?
Well, again, depends where you're operating, but if you are going into the shaded craters, you could expect, order of 100 or so, 100 Kelvin, and if you are in the sunlight fully, you can have higher temperatures, so probably up to 400 Kelvin, I guess, and it's depending on again your there is no atmosphere, so it depends also on the material that you make your rover with, and the reflectivity of it, and your mission scenario, and everything else. So And also, it's not only the temperature, but the temperature cycle depends if how the sun moves over the horizon. So again, depends on your mission and the location and duration.
And a lot of that,
I'll just add that this is a very key question on, like Adrian said, it does depend on your mission scenario. But thermal management on space systems is one of the areas that you've got to work hard to understand, because it's very different than it is on Earth. And so whoever's working your thermal system, your thermal analysis and stuff, is going to have a great learning opportunity on this, because there's a lot of unique features of thermal management for space systems that you've got to deal with. And so that's an interesting, and we'll be looking at that on how you keep your systems warm or keep them cool.
And if you go deeper in the craters, perhaps I should qualify, you get even lower. I don't remember exactly, but maybe 60, 70 Kelvin you could have. So very cold, the coldest temperature that you can think of
in the solar system, pretty much.
Solar system, yes.
and a lot of that information can be found in one of the resources that we've provided to you, what we refer to as the DSNY, the Design Specification for Natural Environments. There's a lot of good information on temperature there. So the next question is, what level of assumption or details can be made for the scalability of our design? Kevin, you referred to this a little bit earlier, but what exactly is meant by scalability? Are you referring to manufacture, like from a manufacturing standpoint, can it be scaled, or from a multiplanetary, like from Moon to Mars?
Well, so again, one thing, in one respect, scalability refers to the fact that maybe in a demonstration you have a certain size, but that design can be fabricated and can be carried and can be deployed in a real mission, and perhaps in a subsequent mission can be made even larger. So that's one form of scalability. There is also scalability potentially taking it from Moon to Mars. So that's a different type of a scenario. And also there is a scalability perhaps in terms of being able to accommodate larger payloads, for example. So a slightly different, perhaps slight modification of your design, but basically being able to carry more, and that also may include packaging and folding, unfolding, and certain areas, certain solutions do not scale well. So that's why you need to kind of pay attention to the scalability aspect.
Another team asked if we could provide more details on what constitutes a minimal level of sensing and autonomy.
So basically, you need to have information about the terrain that you are operating in, and that information can come from a visual type of a sensor, potentially from some kind of force sensor that you have, and so on. So those are what I say would be the minimal things. And again, in terms of autonomy, you need to assume that there is at least a local, well, there is.
I think we may have lost you, Adrian.
Yeah, I think we might have lost Adrian. I was going to add on the autonomy. Autonomy is very hard to do. NASA has a lot of autonomy projects. If you can minimize the autonomy needed in a
high-level mission
scenario, it's probably a good thing. For the basic things, some of the places you want to go in extreme terrain, you've got to realize the communication is a big issue, and it's very challenging, especially in places like lava tubes. And so autonomy is going to be very dependent on your mission scenario. If you're going in a lava tube, I don't know that you can guarantee real-time commanding of your system, because it'll probably have to go through a series of relays, and so the more autonomy would be better if you're exploring a lava tube. So you might want something that has a LiDAR system so it can map the cave to do its route planning and things like that. In other scenarios where you may be able to control it from ground stations, if you're just climbing a slope and can pretty much guarantee line of sight communications throughout its operation. So this is very dependent on your mission scenario.
And as we move to the next question, I'm going to ask our judges to try to have a little bit more concise answers so that we've got about 60 additional questions to get through, plus some in the chat. So we want to make sure to get to everybody. I'll ask quickly, should our system be targeting the functionality of a rover, or would smaller exploratory robots also be considered? Should we develop only just a single rover, or can we develop a swarm of rovers?
Well, you only need support the functionality for your specific case, and both single robots or multiples are acceptable. Again, focuses on mobility. And in terms of the next question, NASA definition of the wheel, we don't have a special definition of the wheel. Everybody would know what the wheel is. So if it's acceptable in general, that's what we call a wheel. But we'd like to go beyond the wheel designs that are currently used in existing previous missions. And basically, it's alternative mobility solutions that have not been used before.
Tori, do you mind taking over for just a minute?
Hi, yeah, absolutely, I can. What is NASA's definition of a wheel? I think, Adrian, you just covered that, correct?
Yes.
Perfect. So the next question, are you allowed to have traditional wheels but with an alternative modality available, sort of a hybrid system?
Again, it could be acceptable, but important is to have a new mobility solution included. And if you have more traditional wheels, then again, you need to justify, but you need to understand there is also a complexity and the cost associated with it, and to understand whether it's efficient or not.
Along those same lines, 16 is, are we allowed to use wheels as long as they aren't motored or aren't the main method of transportation?
You could use whatever you want, but basically the focus is on alternative mobility solutions. So if you use a wheel, but using it for something else, then it's not a wheel from the point of view of a mobility solution.
17, can we leverage wheeled or traditional rovers as part of our architecture? For example, using a wheeled rover to provide power and communication to our system, or to transport our system to a specific location?
It is acceptable, but again, you need to focus on a mobility solution for the extreme terrain. That's the core. That's the essence.
All right. As stated in the proposed solutions assumptions section, can the rover be assumed as a deployable secondary system on board a traditionally wheeled rover, similar to the Mars helicopter?
Again, yes. And you have to describe your assumptions for any system that is needed to implement the use case that you develop.
All right. And I'll let Stacy take back over.
Thank you for that. Can we have multiple subsystems that detach from our mobility solution? For example, to drop off power communication along the way?
Yes.
Can we assume that we'll have the necessary technology to deploy our robot?
You can assume the technology that is available on a NASA commercial rover on CLPS basically system. So, but if you want to have a specialized deployment for that you need to explain it. Again, it will add cost to your mission and complexity.
Next slide, please. Is our rover required to have an appendage for environmental manipulation?
No.
Easy peasy. If we are exploring lava tubes, are there certain geological samples that should be collected? And if so, what size?
Again, you are describing the mission scenario. So if you are basically analyzing it on the spot, you don't need to collect it. It's your mission scenario, so you determine and define that.
How large of openings can we expect inside the lunar lava tubes?
Again, look at the data sets. There are some of the orders of meters. Some could be largest of tens of meters from what I know. But again, I'm not specializing into this. So basically, there is a variety of those. Look at it and define your own mission scenario depending on what you try to target.
I think we're going to have a similar answer here. What sensor data does NASA want inside of the lava tubes?
It's basically what you want to put into there in lava tube, but basically we need to have imagery of there. Spectrometry would be useful. We need to map those things, so LiDAR mapping would be a good start. And again, mobility is the focus of this one, and that it's not related to the sensor instrument or the science mission per se. So focus on the mission. And again, in terms of scenario, we already discussed it's order of kilograms and so on, perhaps in terms of the size of the mass.
And I think we have already touched on temperature, and this, I think the same answer applies here. So let's move on to question number 26.
The lava tubes, it could be not as cold, I guess, as in the permanently shaded crater, but that may be depending where, and we don't really have full information on the let's say, depending on how long the lava tube is and so on.
Perfect. In order to reach a TRL of 5, do we need to test the system in an Earth analog environment? Does the relative environment for TRL5 need to be on site at locations where lunar robots are regularly tested, or will a well-designed test environment at our university be acceptable?
Well, the test environments are important, and but it's very difficult also to simulate all the conditions. So a lunar analog that is perfect, it has vacuum, gravity, simulants, dust, particle size, temperature, radiation. It's very difficult. So you have to focus on the ones that are most related to the mobility solution that you're proposing. So if the mobility is again for a solution that needs to operate in a low temperature, focus on that low temperature thing rather than so again, the testing is very important, but focus it on the key challenge related to your mobility solution.
Okay. Should these missions target primarily early scientific and ISRU exploration, or a later stage of lunar development when we're already living on the moon?
The use of this basically can go beyond the 2026, but the idea is that we could have this mobility solution deployed in this time frame. So if you need later on, again, give a good justification for it.
Are there constraints in terms of energy resources for exploring permanently shadowed regions? And if so, is it restrained to conventional sources, or could it include emerging technologies such as the diamond battery?
2026. Again, if you can convince us that it will be ready for 2026, then you can consider. There is no specific constraint in terms of the energy, but again, in terms of emerging technologies, if it's convincing in your description that it can be matured and flown by 2026, then it's acceptable.
Next slide, please. If we were to explore craters, what would be the approximate size of a crater that we could expect and anticipating when testing on Earth? And what would be an approximate angle of a crater to expect?
I assume that the angle of a crater, you mean the angle of the slope going into the crater. There is a variety of craters, mostly at the lunar south pole around Shackleton crater. Shackleton itself is 20 kilometers diameter, 4 kilometers deep. Some of us have slopes, beyond 20 to 30 degrees, the slope in different locations may be slightly different, but things of the, about 30 degrees or so are very difficult to traverse for conventional wheel vehicles. So for that one, it's important to have a mobility solution. So on the other hand, there could be steeper walls. Those are very interesting to explore because they expose different layers of rock with lots of information on local geology. So steeper will have steeper slopes than that.
Should our robotic system enable sustained living on the moon, such as a robotic mining and transportation system or other prospecting robots for volatiles?
You could enable any of those things, or you could be part of, an exploratory mission. Again, each scenario that you propose will be considered. So there is no specific requirement on living on the moon or mining and so on. So you define your scenario.
How much flexibility do we have with our communications architecture?
You can have all the flexibility that's available related to deployment by 2026. So, but again, for going into certain areas beyond line of sight and so on, unless you put relays and other things in between, you may not have good communication. So you need to kind of clarify that with your assumptions, and the assumptions need to be reasonable.
Thank you. Tori, do you mind taking over for me again for a moment?
Sure. Let's see. So for current systems such as the Viper rover, what is the maximum slope it can traverse?
So basically 15-degree slopes are routine, and even steeper slopes up to 30 degrees. I will qualify this a little bit. It depends also on the how fluffy or how the surface is. So you need to consider those aspects as well in terms of the terrain. But the slope itself is within 15 to 30 is kind of the range.
How much attention should be given to power and communication architectures as opposed to mobility?
Well, you need to describe a system that's operational. The focus is on mobility, but mobility is one component, and the entire system needs to be feasible. And again, communication and so on are depending on your mission scenario, but it's very unlikely that you have long duration video link with high bandwidth and so on, because that adds to a lot of complexity. Through lander, that's more feasible.
All right, and here we've grouped a couple of infrastructure questions. What level of infrastructure, if any, would be established on the lunar surface or otherwise at the point of the Artemis program we aim to support? And a similar question, what can we expect from a NASA commercial or lunar surface system? For example, a mass limit or connection type. And another similar question, what existing infrastructure is in place on the moon to utilize on our mission, or what assumptions can we make about the infrastructure in place?
So I would say that make minimal assumptions about an infrastructure, especially for the early missions. Obviously, there is not much available now, and there will be some communication relay satellite in place. But the focus again is in the short term up to 2026 and so on, and very little infrastructure will be there for support of these missions before that.
Thank you, Adrian. And I'm going to turn it back over to Stacey.
What tools would be available on the moon or nearby satellites for emergencies, such as broken parts that need to be replaced or system failures?
Yeah, I would say that don't rely on it. Not many available parts around.
And can we assume that some portions of the gateway will be built by 2026 and can be leveraged for communication purposes?
The timeline for this, it's a bit uncertain at this moment, but it could be a reasonable assumption if you need a relay for the far side of the moon.
Can we assume that humans will be in the gateway to assist robotic operations?
Let's assume not, for the purpose of your mobility solution. And so in other words, basically assume delays and make a solution that would work without necessarily being controlled from proximity.
Is it our decision to assume whether astronauts are on the moon, orbiting the moon, or their only communications from Earth? Can we assume that humans would be on the moon's surface to assist with these robotic operations?
The mobility, again, solution should work in all cases. Do not rely on teleoperation without delays, or being an astronaut having in proximity to help you to move the robot, or even to be in line of sight. So do not rely on humans to be close for the solution that you're developing.
For robots that run on batteries, should battery stations be considered and constructed as well? Or will there be battery replacement stations, and can batteries be replaced manually?
Well, NASA will not provide you the battery stations and so on. So if you want to have a concept that includes these stations, well, it could be part of your concept of operation. But clearly, it's not practical to have any manual charging of batteries and so on. So if it's automatic charging, again, you have to design the station and include it in your concept.
Do we have to utilize a particular lunar lander?
No, but again, the CLPS landers are probably a good bet, a good start.
For climbing, are there specific locations that we have to use, or can testing satisfy a range of locations?
No specific location is indicated, a requirement, but basically determine a use case scenario, and you determine the climbing requirements. But in general, you understand that you need to be over slopes, larger than 30 degrees and so on, all these other conditions that we discussed before.
Yeah, I'll just add real quick that, I mean, the teams, if they have a mission scenario, they're going to need to develop some performance requirements for their system. And so once they develop those performance requirements, it will lead right into their verification and their demonstration. So it's all dependent on your mission scenario, but certainly you'll want performance requirements for your mobility system. That's going to be a key thing to start with.
And this is Jennifer. I don't know if I can add, and again, if the judges, Stacey, feel free to tell me if we can't say this, but from a lunar lander perspective, I was just going to suggest to probably think of it from an agnostic standpoint, to make it agnostic across all, or compatible, I guess, with all lunar landers. I don't know if we're able to say that, but it's just a suggestion to add.
Yeah, I'll add to Jennifer's thing. The CLPS program office says don't pick a lander, but make sure they'll make sure you understand your needs, your requirements for the lander, and then the CLPS program will competitively source based on your lander needs. And so
Exactly.
the reason to look at the landers is to sort of understand what capability is out there for you to use.
Thank you, guys. The next question is, are there properties of the ferromagnetic dust on the moon that should be considered when creating the design?
There is no guidance in this respect.
All right. Question 43. Are there specific materials that should be considered for the shell or chassis of the system? And are there certain websites that we can search for them?
Again, no guidance. Each mobility system have its own requirements, but look at the resource section to do the NASA Spacecraft Materials Guide.
Should aquatic capabilities, such as moving through bodies of water, also be considered, or is that up to the scope of the individual projects?
Well, I don't know of any big lake or sea that's on the moon, but it could be an interesting added capability if it also is able to move through bodies of water later on. But it's the priority, and it is not the top capability. The priority is for traversing the terrain for the moon. And then again, if it scales to other things, Mars and beyond, it's good, but it's an added feature.
Would wireless systems that interact with each other be discouraged on the moon? And should we expect wireless capabilities to behave the same way on the moon as they do here on Earth?
In principle, yes, you could more or less make the assumption that it will operate in the same way for the context that you're dealing with.
All right, 46 is two different types of questions. First, could a prototype or proof of concept demonstrate our modes of modality and further design details regarding sensing and automation be outlined in the team's report? And the second question, to what extent do we need to demonstrate scientific operations with our system for the verification demonstration?
Yes, to the first question, you can have the concept to demonstrate the mobility and then the designs for sensing automation to be in the report and so on. And basically, the no specific requirement to the scientific operations during the verification demonstrations, but the demonstration needs to reflect what's needed to support the payload that you chose into the use scenario that you defined.
And that actually wraps up the technical questions we received in advance. We've got a section of miscellaneous questions. The first one asking about what phase of the Artemis program are we aiming to support?
I thought, okay, so this is still on us. I thought that it's a, all right. Well, again, you define your own scenario, and it doesn't have to fit with an existing Artemis plan, because it could be a mission of opportunity that is still to be defined, and that will go on future CLPS landers. It doesn't need to tie directly to the program as formulated.
So do Artemis's priorities affect the decision-making process for the finalists? And are the projects that align with Artemis missions, like, will they be prioritized from a judging perspective?
So no, it's basically the criteria that were published. Those are the only criteria that will be used for evaluation. But again, there is an alignment with NASA lunar exploration goals in general, and challenge guidelines. So in that respect, indirectly, there is, an alignment. But the key is to come with new mobility solutions for extreme terrain. That's the most important part.
What is the timeline for NASA's plans after Artemis 3 in 2024? Will robotics missions be first? And what other missions can be completed in craters, such as placing of communication beacons and power systems?
So again, as you mentioned, is not limited to the Artemis specific missions, and you determine basically what's an important scenario, and you describe it, and the commercial landers are basically to be used to the surface, and initial missions to the craters could be science missions, resource mapping, accessing, harvesting water, technology demonstration, and so on. And later on, it could include the development of infrastructure.
The next two questions I'll go ahead and answer from a programmatic perspective. One team asked, can student organizations be a partner in the same capacity that an industry partner would be? And the answer is no. If you're utilizing a student organization on campus, we would consider them part of your student team. And can 2021 Big Idea participants, or even older participants, could some of those finalists be contacted for inquiries or use of their technology? And the answer is that we're happy to try to connect them with you. We're not going to provide their contact information just because that wouldn't be very fair to them, but we will let them know that you're interested. If you can send us an inquiry via email to our Big Idea email address that's listed there, bigidea@nianet.org, and let us know which teams that you want to reach out to, and we'll send them a message on your behalf. And if they would like to reach back out to you, they'll be welcome to do so. So we're happy to make those connections if we can. Sometimes it's hard to find them because they've moved on or graduated or gone on to other things, but we'll try our best for you. What are common problems that NASA has faced when designing rovers, Adrian?
Well, this is a very, very broad question. I mean, and it depends a lot, the answer, on where is the rover supposed to go, what is the duration of operation, the mission, and many, many aspects. But in general, for lunar environment, is surviving that environment. Again, the temperatures that were mentioned, dust, radiation, and so on, and then the traverse of the terrain and that was mentioned, which requires the new mobility solution, and you need to have a system that's reliable. But again, each mission has a different optimal design depending on the mission requirements.
Is there a template available for failure mode analysis?
Nope.
Are there any specific documents, I think we addressed this up front, that we're going to be looking for risk review, bill of materials, et cetera? And the answer is no to that. How detailed does the risk mitigation plan have to be? How should we present risk mitigation? Should we use the failure modes and effective analysis chart, for example, or is there any other template we should use?
Kevin, do you want to pick up for a second?
Yeah, I don't have a lot to add on this beside what's already discussed in the answer. Like I said, you look at your tall poles and the unique risks for your mobility system and try to come up with validations or verifications that can show that you've mitigated these risks. And so we don't want you going off and solving risks that are not really part of your system of interest, but focus on the key risks on your mobility system. It might be stabilization, it might be operating in the extreme temperatures it might be the lunar dust. Those are a little bit harder. But focus on the risk for your mobility, and that's going to come down to performance requirements. You've got the performance and environmental requirements that your system has to meet, and so look at those and try to pull out the ones that you can advance the state of the art and improve the TRL on it.
Convince us that you've at least thought about it. All right, should we design a 180K concept at a high fidelity, or will a cheaper, lower fidelity concept or prototype be acceptable?
Well, again, you need to do at the fidelity that is needed to demonstrate the effectiveness of your solution. So, and each solution would have different requirements. Basically, you need to make sure that your demonstration scales. Again, I'm using this term towards a flight like demonstration to the fullest extent possible, and that involves potentially the testing, hardware, and so on. But basically, you need to focus on reducing the unique risks, the unique technical risks for your mobility solution. That's the core.
We received another question that does not seem to be relevant, so let's skip on to number 12. Oh, we don't have a 12. So this is where, Adrian, you get a break, and Tori is going to ask some questions here.
I will. So, Stacy, what is the level of design maturity for the proposal?
We kind of covered this up front, but it's the convincing level. It just you need to have adequate enough information to convince the judges that your team can effectively build your prototype system and one that works. So again, take a peek at that proposal evaluation criteria and make sure that you are addressing those technical credibility components of that.
Along those same lines, is there an expectation that we should have a manufactured anything to test before the proposal is due?
No, but that doesn't mean that you can't if you have the ability to.
Are there sample templates of a project proposal you'd be expecting for submissions?
So we don't provide specific entire project proposal templates, but there are certain templates that we do include, and they are listed there under proposal files must include. We have a quad chart template we ask you to use, the budget template that I mentioned at the beginning, and we do have a couple of templates for some of the supporting letters that we'd ask you to include.
So this is kind of a long one, but beside the budget spreadsheet template and the budget justification template, is there any other information that we should include in the budget section of our proposal?
Yes, it's listed here. It's listed on the website. It's listed in your guidelines document. So I'm not going to go through all of it, but we definitely want to make sure that you guys are taking a really good look at what is supposed to be included. Really look at those budget instructions and don't leave anything out, because failure to comply with the proposal requirements may mean that you're ineligible, even if you have an amazing idea. So really take a good look at that. We even include costs that are normal and allowable, and then some costs that are not allowable. One thing I do want to point out right now is that the tuition and fees is an unallowable cost in the Big Idea program. You can have stipends for doing research. You can obviously have funding for materials and supplies. Even faculty salary can be included. But salary and stipends cannot be supported for non-US citizens. Travel cannot be supported for non-US citizens because this is government taxpayer dollars, and they just have those restrictions on there. So definitely take a peek. We will ask for anybody who plans on traveling to the forum that you do include a registration fee for each person, planning on about $550 per attendee. Plus, we've given you a couple of nights, and you want to put lodging and all of those sorts of things included. We're planning on having the forum in Pasadena, California, out there right near JPL, and may even get to do some tech demos of your systems out in kind of the deserty mountain area, an hour or two outside of JPL. So we have some fun things planned for that, and make sure that's included in your budget.
All right. Does everyone need to talk or play an active role in the proposal video? We have a lot of team members, with some of them not participating quite as much as others.
You definitely do not need to have everybody talk or participate. And if it's hard to get everybody together or on camera, and I know you have a short period of time, it would be really nice for us. We encourage you to take a team photo, or at least provide kind of a wall of faces if you can get together on a WebEx or a Teams meeting or something like that, Zoom meeting, and just kind of take a screenshot of everybody. We just want to see who's on your team. It helps us to feel a little bit more connected to each of the teams.
For eligibility, does the main advisor have to be a U.S. citizen, or is it enough that one of the additional advisors is a U.S. citizen?
The main faculty does need to be a U.S. citizen. And the only reason for that is because they're going to be responsible for receiving the funds, and that's a restriction on the funding.
If a team has at least 5 U.S. citizens, would they be able to support additional non-U.S. participants and still be eligible for the competition and funding?
Yeah. If there's 5 U.S. citizens still on the team can also have additional non-U.S. citizen participants. But again, remember that there are some restrictions that those non-U.S. citizens cannot receive travel funding or stipend support.
Do green card holders count as U.S. citizens for the minimum or maximum team member citizenship requirements and for budgetary requirements?
So unfortunately, we do not have an answer for you right now. The green card holder situation is a tricky one at NASA, and in some circumstances they're treated just like U.S. citizens. In some circumstances they're not. So we've put in a request to NASA's legal office to provide final clarification on this for us, and as soon as we have that clarification, we will make sure to update the FAQs page. So come back and check the FAQs page, and we will make sure that we answer that as soon as we have the information available.
Who, title-wise at the university, will be the primary person in charge of funds if they are received in February?
That would be your primary faculty advisor. And every university has a different process for getting access to those funds. So we encourage your faculty advisor to talk with the university about their protocols. Generally, it's managed through the Office of the Sponsored Programs or Sponsored Research Office, but just find out what they need to do to be able to access those funds.
And what if prices change for the budget?
I think I mentioned up front that your budget is your budget. So once you've given us what your budget is, we will have, if you are selected as a finalist, we will release that amount of funds, but that's all that we have available to us to provide you at that point. We can't give you any more later on. So what several teams have done in the past is they'll actually build in a little bit of a margin of error, maybe 10% of their budget, to allow for an increase in cost. And that's a justifiable budget expense.
Is the forum at NASA JPL? And another question that we actually received in the chat, will international students and non-US citizens be allowed to attend the forum at JPL?
So the answer to that is probably. we do anticipate holding some of the forum at least at a hotel in Pasadena, and anything that's held at a hotel will absolutely be acceptable. For our foreign national participants at JPL, there is a process. We have to apply for permission for you to be able to come on. It's a 30-day process. And as long as you're not from a country that's considered a designated country, that is something that the government is watching for security reasons, we generally don't have trouble getting non-US citizens onto JPL. So we will let you know more once we get closer for those finalists. If you have anybody who's a foreign national and you are a finalist, reach back out to us next summer and we can have better answers for you then.
Are we allowed to have an appendix in the proposal paper for additional information, and would this count toward the page limit?
Do not include things in the appendix except for references. So we want your works cited and your references in the appendix, and that's it. The judges are not expected to read, nor do they need to feel compelled to read anything else that is in there. The work that you are proposing needs to stand alone inside of the body of your proposal.
All right, and this is one of the last questions that we have here on our PowerPoint. If there are any additional questions, who can we reach out about these?
So everybody, please make note of this. Moving forward, should you have any questions, we are here for you. And just send us an email to our bigidea@nianet.org email address. It's all over the website. Tori just put it in the chat. It's here. We're going to provide these slides to you, and it will be on the FAQs page as well. But if you have a question, send it to us. And if Tori and I or Janice cannot answer that, we will send it over to our lovely panel of judges and ask them for an answer. Once we have the answer from the judges, we will actually email you back personally, but we'll also post that answer onto our FAQs page because we want to make sure that we have a very even and fair playing field. Every student has access to all of the same information that any other student has. And in the same regards, we do ask students not to reach out to the judges directly. This is a conflict of interest and is unallowable in our program. If you do choose to reach out to one of our judges, they've all been instructed to tell you that they can't talk to you and to send your questions to us. So just want to make sure that that's really clear. All questions have to come through the Big Idea program office, and we'll make sure that we get a written response to you. And with that, I think that's the end of our questions. So let's go ahead and scroll back up. Tori, if you could ask us questions. Oh, and I guess really quickly before we get there, there is a little QR code here on the screen. If you guys want to hold your camera up to that on your cell phones, that is a direct link to a printable version of the challenge guidelines where everything is just listed out for you, including all the things that have to be in your budget and your proposal. It's a really easy way to look at the information. Sometimes the information on the website is kind of spread out between multiple pages and can be a little bit difficult to find. Use this QR code here to go directly to those printable guidelines. You can do a search for terms and have everything really at your fingertips. So we want to make sure that you guys all have access to that. And let's go ahead and jump back up to the first questions that came in on the chat. If you have any more, please feel free to go ahead and write them in. We've got a few more minutes. And if there are any questions that come in on the chat that we are not able to get to, we will add them to our written transcript with written answers that we'll be sending out to every team in about a week. So we will answer your questions even if we don't get to them today. I want to make sure everyone knows that.
So I'll go ahead and start asking questions from the chat. Adrian, Stacy, Kevin, if the question has already been answered by some of the other questions that we have gone over in the PowerPoint, please feel free to mention that so that we can remain consistent in the answers, of course, but also so that the students can go back and look at that later. How important is it to prove during our time frame that the mobility concept can be done autonomously?
Well, I think it's important to demonstrate that it doesn't require a continuous presence of a human. So it's not something that you can do without delays or without interruptions. And it can be done basically with the communication conditions that we assume to be available by that time. So I would say that the system needs to have a mobility that doesn't really depend on a human for the mobility portion of it.
What should the lifetime of our mobility systems aim to be?
That was answered.
Excellent. In regards to the requirements of our rover, is there any specifications on what scientific equipment these rovers could carry? Will it be determined by our proposed mission?
That was answered.
Awesome. If we find earlier evidence that NASA has looked into similar concepts but cannot find any actual documentation, could we request access to further data?
Well, I guess if that is not that should not prevent you from doing the full due diligence. I mean, we don't know exactly, but in principle, if there is some information that's referred and it cannot be available on the internet by any means, you could ask for it and we'll try to see if we can accommodate.
Thank you. Are there rules against using COTS parts or systems? For example, an existing robotic platform to be modified?
Can be modified, and if it survives the environment and if you can show it would basically work in the conditions over there, it's potentially useful. I see Kevin has a comment here.
Yeah, I was going to say, if you can integrate COTS parts into your system, obviously you're going to integrate a lot of COTS parts. The level of integration, we don't want you to go off and buy an off-the-shelf walker and say that's your mobility system. That's not quite what we want, but you can certainly, the level of subsystem integration should be, can be fairly high, but we want your own designs and not an off-the-shelf system that solves your problem.
It's very unlikely that any off-the-shelf system would solve the problem for mobility on the moon in the conditions that we have specified in the requirement or the proposal.
Thank you, gentlemen. How much can our proposal depend on reconnecting to the lander for sub-processes, or does our system need to be completely independent?
I'm sorry, I'm not sure I got it. Kevin, maybe you want to answer that. I'm not sure that I got fully the meaning of the question.
I'm trying to understand what this is talking about. Obviously, if you need to get power from the lander to recharge, you'll have to move to the lander. In addition, you'll have to get the CLPS provider to provide a power outlet for your rover. Obviously, communications are typically standard, a standard that's provided by the lander, but you can look at the user's manual on it. So other than power and communications, occasionally the lander will provide a command interface that can provide time updates, timestamp updates, or maybe some positioning data. Yeah, this question is a little open-ended for me to answer, so I can't go much beyond that.
And before we go any further, we are pretty much at our time limit. I do want to ask Adrian and Kevin, if you have a few minutes to remain on, we could probably continue. But if not, we are at the time limit. So let me know what your thoughts are on that.
I can hang around.
Okay.
Yeah, I don't think we have a lot more questions to go through. So.
Okay, thank you both. That's very kind of you.
Excellent. And if there are any questions that you want to think about, and we can go ahead and pop that into the summary document that will be made available to all of the teams after the Q&A session, either toward the end of this week or at the beginning of next week. So just keep an eye for that. If your question does not get answered here, we'll try to provide an answer then. So what would a good assumption be for payload volume? I think that was addressed.
Yep.
All right. Let's see. If we assume there is little infrastructure on the moon, are we responsible for developing a fleshed out power system that includes energy harvesting and storage? Or can we utilize existing power systems that have been proposed and just consider the estimated power delivered to the rover?
Again, the focus is on the mobility solution, and if the assumption is that you could come back to the lander, potentially that is, let's say, a feasible solution if you want to operate more than the duration of a few hours. If you don't have, let's say, solar panels and or other type of thing into your design. But don't assume that will be, for example, any power beaming available to you or anything into that time frame.
Okay.
Yeah, I was just going to add, I think in one of our earlier challenges, we said don't assume RTGs are available. They are extremely expensive, and for most lower cost missions, RTGs, they don't provide a large amount of power, and so you should try to look at solutions that don't require RTGs.
So I'm going to ask a question that I've already answered in the chat and provide the answer. Oh, would it be
For that,
possible to see previous successful proposals? And the answer is great question. We do not share prior proposals, but you can view prior proposal videos and final technical papers on the Big Idea website. All right, and we already answered the question about international students. There's a question here. Does U.S. citizens include people with multiple citizenships?
As long as U.S. citizen is one of those, that counts.
All right, and there's an answer for this question available on the FAQs page as well. Is there a certain format our references should be in? So go ahead and check out the FAQs page for the full answer, but in summary, there is no required format, but it must be consistent, and simply putting a link to a resource is not an acceptable form of listing your references. Can we have soft money allocated in our budget?
It depends on what you mean by soft money. As long as it's not something that's unallowable, like you can't spend it on meals or pizza for your team while you're working and that sort of thing. You are allowed to have some money that you don't know exactly what it's going to be used for contingencies.
All right. Can we approach NASA contractors as industry help or NASA themselves, or is that a conflict of interest?
You are allowed to approach both NASA contractors and industry and even some civil servants at NASA, as long as they are not one of the judges on the Big Idea Challenge, nor can they be somebody who is directly doing work with the Game Changing Development Program who sponsors this program.
Thank you, Stacy.
and don't approach my management to put me to answer.
Will these slides be available to download afterward? Yeah, so these slides will be available to download at the same time as the summary document will be available, as well as the recording of this session. So you guys will be able to find that on the same place, which will be the Big Idea 2022 FAQs page. And our final question, should we focus on keeping the power drain of our modality minimal, or is that more of a secondary consideration?
Depends on, again, how long you want to operate and what is your mission scenario. I guess it's always a trade-off between the power consumption and the duration of your operation and so on. So it depends on the case that you're proposing.
And I'll say, power is just a very precious resource in space missions, especially on the lunar surface. And so it should always be minimized if you can.
All right, and that is the end of the questions that we have in our chat. Thank you so much, Adrian and Kevin and Stacy. If you have any other questions, please feel free to direct them to that bigidea@naanet.org email address. Again, all of these documents will be posted to the FAQs page, and I'll turn it back over to Stacy.
I think, Tori, you just wrapped up everything I'd like to wrap up with. So I'll just say thank you again, Kevin and Adrian, for all the time that you provided answering these questions in advance and participating today, as well as our other judges that are on the line. We value you guys so much. And for all of our students and faculty, we value the work that you are contributing to NASA's mission. And we are so excited to see your proposals come in. So please don't hesitate to reach out to us. We are on your side. We're rooting for all of you. And that proposal deadline is coming up January 18th. We realize it's really close when you get back to school, so try to make sure that you plan ahead before you leave and work with your Office of Sponsored Research Programs well in advance and making sure that they've got your budgets covered. We cannot accept late proposal, so they need to be in by midnight on the 18th. And we look forward to it. Have a good weekend. Adrian, do you have something else to say? Oh, Adrian.
Yes, I just wanted to thank one more time the judges and again Kevin and Jennifer. Jennifer answered a couple of questions, but I also want to thank Eddie Tunstall. I didn't hear Eddie too much. Eddie, if there is anything else that you'd like to actually say during this meeting, this is the moment.
Thank you for the opportunity, Adrian. I don't have anything to add, though. Thank you.
All right. Thank you, everyone, then.